We are going to start now lecture 11 of chapter 9 class 11th mathematics sequence and series. So in this lecture we will discuss some properties related to the relation between arithmetic mean, geometric mean and the harmonic mean. And further we will solve certain problems based upon the sum of infinite series. So first thing we have is that let A and B be two real numbers which are positive and unequal, and A, G and H are the arithmetic, geometric and harmonic mean between them. Then we are saying that A, G and H form a GP, that is G square is equal to A into H. We have to prove this thing. And second is that arithmetic mean is greater than geometric mean is greater than harmonic mean. The arithmetic mean is greater than geometric mean. This thing we have already proved in our previous lectures. So first thing we have is the value of A, we have it is A plus B by 2. The value of G we have it is square root of AB, and the value of H we have that is equal to 2AB by A plus B. Now if we substitute these values in this equation, we are saying we get H is equal to the value of AB we have that is equal to G square. So we are getting it is 2 times G square over the value of A plus B that is equal to 2 times A. So this implies us that G square is equal to A into H. So this is the first part we have to prove, that G is the geometric mean between A and arithmetic mean and harmonic mean. Next is we have to prove that A is greater than G is greater than H, and the first part, that is arithmetic mean is greater than geometric mean, this thing we have already proved in our previous lectures. This first part, that A is greater than G, this is being proved in our previous lectures. So what we obtain from this is that A by G is greater than 1. Now from this result that we have proved, that is G square is equal to A into H, we see that A by G is equal to G by H, and combining both these results we obtain that G by H is greater than 1. So this implies us that G is greater than H. So what we obtain from this is that arithmetic mean, combining these results we obtain A is greater than G is greater than H, arithmetic mean is greater than geometric mean is greater than the harmonic mean. So this result, it can be written in the form, for n terms it can be written in the form arithmetic mean is A1 plus A2 plus so on up to plus An divided by n, this is arithmetic mean. This is greater than equal to A1 into A2 so on up to An, this is the geometric mean between the n numbers, and this is greater than equal to n upon 1 by A1 plus 1 by A2 so on up to plus 1 by An. And this equality will hold only when all these numbers A1, A2, A3, An they are equal, that is we are talking about the constant sequences. We are saying sign of inequality holds when all these numbers these are equal. Now next we have is if A, G and H are arithmetic, geometric and harmonic mean between A, B and C, three numbers are given. So we are saying A is equal to A plus B plus C by 3, G cube is equal to A, B, C, and H is equal to 3 by 1 by A plus 1 by B plus 1 by C, and if you solve this value you will obtain the answer, it is 3ABC by AB plus BC plus CA. So we obtain from this that AB plus BC plus CA that is equal to H by or 3ABC by 3ABC by H. Now we are talking about an equation whose roots are A, B and C. So the form of the cubic equation that will be x cube minus sum of the roots A plus B plus C times x square plus sum of root taken 2 at a time AB plus BC plus CA times x minus product of the roots A, BC is equal to 0. Now from this first equation from this first equation, we get a plus b plus c is equal to 3 times a. So we are writing x cube minus 3 times a x square plus, from this equation it is 3abc, abc is g cube. So we are getting it is 3g cube by h times x, and last it is minus abc, so it is minus g cube is equal to 0. So we are saying that this is the required cubic equation. This is the relation, this equation, this gives us the relation between a, h and g. That is, if arithmetic, geometric and harmonic mean are given, we have to calculate the three numbers, then we have to solve this cubic equation. If we solve this cubic equation, we obtain three roots, and those three roots that we obtain, they have a, g and h as the arithmetic, geometric and harmonic means. Next is the geometrical proof of the fact that arithmetic mean is greater than geometric mean is greater than the harmonic mean. So we are saying, suppose we are plotting, we are having this is the x-axis, this is the y-axis. We have marked a point, this is the region O. We have marked a point OA unit. We are saying this is the point, say A, and the length of this is A units. We have marked another point B, and the length of this is B units. And next we are drawing the circle or the semicircle with AB as the diameter. This is the semicircle. This is semicircle with AB as diameter. Now if we draw a tangent to this circle from the point O, from this point O, we are going to draw a tangent to this circle, and this point we are saying this is T. And this TM we are saying, this TM is perpendicular on OX. This is the perpendicular on AB, or we are saying this is perpendicular on the x-axis. And we are saying that suppose C is the point that is the center of this circle. It is the center of this circle. Then we obtain that OA, we are talking about the length OA plus OB, we are talking about OB. We are saying OA plus OB by 2, that is equal to, in place of OA we can write it is OC minus AC, plus second term we can write it is OC plus CB divided by 2, and this value is equal to, if you solve this result, this AC and CB, they are equal, they are the radius of this circle. So we obtain this is equal to OC. So what we get from this is that OC is equal to A plus B by 2. So this implies us A plus B by 2 is equal to the arithmetic mean between these two numbers. Now since OT is the tangent, we are saying this OT is the tangent, and we know that OT square, that is equal to OA into OB. So this implies us that A into B, we are saying OA and OB, their values are A and B, that is equal to G square. So what this thing means is that the length of this tangent, this is basically the geometric mean. The length of this tangent OT, this is basically the geometric mean. Now further, we are talking about the two similar triangles. One is the triangle OCT. One is the triangle OCT that we will obtain if we join these two. T and C we have joined over here. We are talking about this triangle. And second triangle we are considering, it is the triangle OMT. We are considering these two triangles. Now in these two triangles, we have OM over OT. Both these triangles, these are similar to each other. That is equal to OT over OC. And from this, if we calculate the value of OM, we get that is equal to OT square divided by OC, and that is equal to AB by A plus B by 2, that is equal to 2AB by A plus B. So this gives us that OM is basically the harmonic mean. This is the harmonic mean, and it is clear from the figure. We are saying the value OM that we have, this is the harmonic mean. This value OM we have, it is harmonic mean, and the value of OC we are saying that is arithmetic mean. Now it is clear from the figure, from this figure it is being clear that the value of A is greater than G is greater than H. So we are saying these are the three means we are talking about. This G is the length of this tangent, harmonic mean is the length of the point O to this perpendicular, and this OC is the arithmetic mean. So clearly we obtain that arithmetic mean is greater than geometric mean is greater than harmonic mean. Next we have is, if A raised to the power x is equal to G raised to the power y is equal to H raised to the power z, where A, G and H are the arithmetic, geometric and harmonic mean between two given quantities, then we have to prove that x, y, z are in harmonic progression. So if we consider these values is equal to k, we obtain A is equal to k raised to the power 1 by x, G is equal to k raised to the power 1 by y, and H is equal to k raised to the power 1 by z. Now it is given that A, G and H, these are the arithmetic, geometric and harmonic means, and we know that the relation between these three it is given by G square is equal to A into H. So we substitute the values over here and we obtain that k raised to the power 2 by k 2 by y, that is equal to k raised to the power 1 by x into k raised to the power 1 by z. So this is equal to k raised to the power 1 by x plus 1 by z. So combining both these results, we obtain that 2 by y is equal to 1 by x plus 1 by z, and this thing proves that 1 by x, 1 by y and 1 by z are in arithmetic progression. That is, it proves that x, y, z are in harmonic progression. Next is the harmonic mean between two numbers is 4. So the value of h is given to be 4. Arithmetic and geometric means are a and g, and it is given that they satisfy 2a plus g square is equal to 27. Now we know that the relation between arithmetic, geometric and harmonic mean is g square is equal to a into h. If we substitute h is equal to 4 over here, we obtain g square is equal to 4a. If we substitute this value over here, we get 2a plus 4a is equal to 27. So we get 6a is equal to 27. So we get a is equal to 9 by 2. Now if a is equal to 9 by 2, the value of g square we obtain it is 4 into 9 by 2, that is equal to 18. This is the value of g square we have. Now we have to calculate the value of a and b. Now we know that if a is the arithmetic mean and g is the geometric mean between two numbers, then the two numbers they are given by a and b, that is equal to x, that is equal to a plus minus square root of a square minus g square. So the answer we obtain it is 9 by 2 plus minus square root of 81 by 4 minus 18. So the answer we obtain it is 9 by 2 plus minus 3 by 2. So we are saying that the two numbers they are either 6 and 3 or 3 and 6. Now next is, if the geometric mean is 1 by n times the harmonic mean between two numbers. So it is given that g is equal to 1 by n times h. Then show that the ratio of the two numbers is this. Now again we are talking about, we have g square is equal to a into h. So if we substitute this value over here, we obtain 1 by n square into h square is equal to a into h. This h gets cancelled. So this implies us that the value of a we have, it is h over n square. This is the value of a that we have. Now we have to calculate the ratio of the two numbers. We know that the two numbers whose arithmetic and geometric means are given, a and b, they are given by the formula a plus minus square root of a square minus g square. Now if we substitute the values over here, we are saying the value of h is over n square, this is value of a, then it is plus minus square root of h square over n raised to the power 4 minus h square over n square. So this is equal to h by n square plus minus h by n square root of 1 by n square minus 1, and this is equal to h by n common, or we can write h by n square common. Why? Because when we take the LCM over here, this thing will become 1 minus n square by n square, and this term will become n square. And what we are left inside is that 1 plus minus square root of 1 minus n square. Now we have to calculate the ratio of the two numbers. So the ratio of two numbers a and b, it is h by n square into 1 plus square root of 1 minus n square divided by h by n square into 1 minus square root of 1 minus n square. We are saying that this h by n square get cancelled, and we are left with is 1 plus square root of 1 minus n square over 1 minus square root of 1 minus n square, and this is the required result. This is the required ratio. Now next is if three positive unequal quantities a, b, c are in HP, we have to prove this result. So we start with the left hand side of this. It is a raised to the power n plus c raised to the power n. We can write this is equal to a raised to the power n by 2 minus c raised to the power n by 2 whole square plus 2 times a raised to the power n by 2 c raised to the power n by 2. Now this term we are seeing, this is a positive term. So what we have obtained, that a raised to the power n plus c raised to the power n, we are saying this is some positive term. It is always greater than 2a raised to the power n by 2 c raised to the power n by 2. Now this a, b, c, these are given to be in HP, and we know that the geometric mean is greater than the harmonic mean. We are having the numbers a and c. So a, b, c, these are the three numbers. So if we are talking about the numbers a, b and c, then we are writing the geometric mean between a and these two numbers. It is a c square root, and it is greater than the harmonic mean. Harmonic mean, these three numbers, these are in HP. So harmonic mean between these two is b. So it is greater than b. So if we take the power nth power on both sides, we obtain that a raised to the power n by 2, c raised to the power n by 2 is greater than b raised to the power n. If we multiply both sides of this equation by 2 and combining these results, we are saying that this is greater than 2 raised into b raised to the power n, and this is what we have to prove. That is a raised to the power n plus c raised to the power n is greater than 2 times b raised to the power n. We have proved this result. Next is, if a, b, c, d are 4 distinct positive quantities in AP, then we have to prove that BC is greater than AD, and we have to prove this result. So we are saying A, B, C, D are in AP, and we know that the arithmetic mean is greater than the geometric mean. Now the arithmetic mean, we are saying this B we are talking about, it is greater than geometric mean, that is greater than AC, and the second number from this what we obtain is square root of AC. So this implies us that B square is greater than AC. Now the second thing we can obtain from this is that C is greater than square root of BD, and this implies us that C square is greater than BD. Now from both these equations, if we multiply the values, we obtain b square c square is greater than a c b d. All these numbers, these are 4 positive quantities. So this b and c gets cancelled, and what we obtain is that b c is greater than a d. So this is the first part we have proved. Second result we have to prove is this. So we are using the result that arithmetic mean is greater than the harmonic mean. So we have b is greater than 2ac by a plus c, and c is greater than 2bd by b plus d. Now from this first result, we have a b plus b c is greater than 2a. From the second result, we have b c plus c d is greater than 2bd. This is AC. Now from these two equations, if we add all these values, we will obtain AB plus BC plus CB plus CD is greater than 2AC plus 2BD. So this gives us that AB plus CD is greater than 2 times AC plus BD minus BC. Now if we divide all these terms with A, B, C, D, we obtain the required result, that is 1 by CD plus 1 by AB is greater than 2 times 1 by BD plus 1 by AC minus 1 by AD, and this is the required result. Now next we have is, if A, B, C, D are the 4 distinct positive quantities in GP. So these numbers now they are given to be in geometric progression. We have to prove that A plus D is greater than B plus C. We know that the arithmetic mean is greater than the geometric mean. Now arithmetic mean between A and C is A plus C by 2 is greater than B. This implies us A plus C is greater than 2B. And if we consider the 3 elements B, C, D, we obtain B plus D by 2 is greater than C. So this implies us that B plus D is greater than 2C. Now if we add these equations, we obtain A plus B plus C plus D is greater than 2B plus 2C. So this implies us that A plus D is greater than B plus C. These values we obtain. This is the first result. Now second is, we are using the inequality that geometric mean is greater than the harmonic mean. So for the first 3 terms, the geometric mean is C. We obtain it is greater than 2BD by B plus D. For the next 3 terms, these are for the last 3 terms, these are for the first 3 terms, we have B is greater than 2AC by A plus C. Now from both these equations, from this first equation, we can write BC plus CD is greater than 2BD. From this equation, we can write BA plus BC is greater than 2AC. Now if we add all these equations, we will get AB plus BC plus BC plus CD is greater than 2AC plus 2BD. And on solving this, we obtain that AB plus CD is greater than 2 times AC plus BD minus BC. Now if we divide whole of this equation with ABCD, we divide it with ABCD, we obtain that 1 by CD plus 1 by AB is greater than 2 times 1 by BD plus 1 by AC minus 1 by AD. So this is the required result that we have to prove. This is the required result that we have to prove. Now the next question we have is, if A, B, C, D, these are the 4 numbers which are in HP, we have to prove these 2 results. So again, for the first case, we are saying that arithmetic mean is greater than the harmonic mean. So we get A plus C by 2 is greater than B. Second, we are getting b plus d by 2 is greater than c. This implies us that a plus c is greater than 2b. This implies us b plus d is greater than 2c. If we add both these equations, we will obtain a plus d is greater than b plus c. So this is the first part we have proved. For the second part, we are considering that geometric mean is greater than the harmonic mean. So we get square root of AC is greater than B and square root of BD is greater than C. This first one implies us AC is greater than B square. This second implies us BD is greater than C square. Now if we add both these equations, we obtain AC plus, in place of add, we are multiplying these terms. It is BD is greater than B square C square, because all these terms are positive. So we can multiply these terms, the sign will remain same. So this B and C gets cancelled and we are left with is AD is greater than BC. So this is the second part that we have proved. So we are saying that if they are HP, they satisfy these relations. Now the next thing we have is arithmetico-geometric series. So we are talking about a particular kind of series. It is a series formed by multiplying the corresponding terms of an AP and a GP. It is called arithmetico-geometric series. It is written in short form as AGS. So we are saying, suppose we have an AP, it is 1 plus 4 plus 7 plus 10, so on. This is an arithmetic progression. We have a GP, it is 1 plus x square plus x cube plus so on. If we multiply the corresponding terms of both these, we get it is 1 plus 4x plus 7x square plus 10x cube plus so on. So we get an arithmetico-geometric series. Now we are saying the general terms, if we want to write, we are saying the general term of an AP, it is written over here. It is a plus g, a plus 2d plus so on up to a plus n minus 1 d. The general terms of the GP, they are 1 plus r square so on up to r plus 1. And if we are saying that we multiply these terms, then we are getting it is a plus d times r plus a plus 2d times r square plus so on up to a plus n minus 1 d times r raised to the power n minus 1. And this is the standard form we are saying for the arithmetico-geometric series. Now next we have is the sum of n terms of an arithmetic geometric series. So suppose we are writing the value of Sn, that is equal to a plus d times r plus a plus 2d times r square plus so on up to plus a plus n minus 1 d times r raised to the power n minus 2 plus a plus n minus 1 d times r raised to the power n. This term we have it is n minus 2. Now if we multiply the both sides of this equation with r, we obtain r times Sn, that is equal to ar plus a plus dr square plus so on up to, when this term is multiplied with r, we will obtain a plus n minus 1 d r raised to the power n minus 1. This power over here, it is n minus 1. This power we are saying this is n minus 1. And the last term we will obtain, it is a plus n minus, this is n minus 2 minus 1 d into r raised to the power n. Now if we subtract both these terms, we are talking about the value of r Sn minus Sn. We are subtracting these values. The answer we are getting, it is a plus dr from these terms. By subtracting these terms, we are getting dr. By subtracting these two terms, we are getting plus dr square so on up to, by subtracting these last two terms, we are getting dr raised to the power n minus 1. and last term we have it is a plus n minus 1 d r raised to the power n. Now from this what we get is the value of Sn we have, that is equal to a over r minus 1. Now sum of these terms we are saying it is dr into, we are subtracting these values, so this sign over here, this is negative sign over here, so we are getting dr into 1 minus r raised to the power n minus 1 over this r minus 1 into Sn is there, this r minus 1 we are writing on this side, it is r minus 1 square, and minus a plus n minus 1 d r raised to the power n over r minus 1. So this is the final formula for the sum of n terms that we obtain. Next is to reduce the sum up to infinity. We have obtained the sum as Sn is equal to a over 1 minus r plus dr over 1 minus r square minus dr raised to the power n over 1 minus r square minus a plus n minus 1 d r raised to the power n over 1 minus r. Now the first condition we have is that mod of r is less than 1. So if mod of r is less than 1, this implies us that r raised to the power n approaches to 0 as n approaches to infinity. So if we take the limit over here, we are saying S infinity is equal to a over 1 minus r plus dr over 1 minus r square. This r raised to the power n approaches to 0. This r raised to the power n approaches to 0. Both these terms they are approaching to 0. So this term will become equal to 0. So the sum of infinite terms, the answer we have, the sum of infinite terms, that is equal to a over 1 plus minus r plus dr over 1 minus r square. So this is the sum up to infinity. This is the sum up to infinity. Now next we have certain problems based upon these formulas. So first is we have to find the sum of this series. So in this series we are saying this is an arithmetic geometric series. How? We are writing it is 1 plus 4 into 1 by 5 plus 7 into 1 by 5 square plus 10 into 1 by 5 cube and so on. So the AP we have it is 1 plus 4 plus 7 plus 10 and so on. And the GP we have it is 1 by 5, 1 plus 1 by 5 plus 1 by 5 square plus 1 by 5 cube and so on. So this is the AP we have and this is the GP that we have. So we are saying that the nth term, if we write Tn, we write it is nth term of this AP, the nth term of this AP, that is given by 1 plus n minus 1 into 3 into the nth term of this GP. The nth term of this GP is 1 into 1 by 5 raised to the power n minus 1. So the answer we obtain, that is equal to 3n minus 2 into 1 by 5 raised to the power n minus 1. So we are saying that Tn minus 1 is equal to 3n minus 5 into 1 by 5 raised to the power n minus 2. Now next we are going to calculate the sum up to n terms. So we are saying the given series, it is Sn is equal to, given series Sn is equal to 1 plus 4 into 1 by 5 plus 7 into 1 by 5 square, so on up to plus 3n minus 2 into 1 by 5 raised to the power n minus 1. Now if we multiply both sides of this series with 1 by 5, we obtain 1 by 5 Sn is equal to 1 by 5 plus 4 into 1 by 5 square plus so on up to plus 3n minus 2 raised to the power into 1 by 5 raised to the power n, and the term before this, it will be 3n minus 5 into 1 by 5 raised to the power n minus 1. Now if we subtract both these values, we will obtain Sn into 1 minus 1 by 5 that is equal to 1 plus 3 into 1 by 5 plus 1 by 5 square, so on up to plus 1 by 5 raised to the power n minus 1, and last we have is minus 3n minus 5, 3n minus 2, this value is 3n minus 2 into 1 by 5 raised to the power n. This value we are talking about, this is the last term over here. So what we obtain on solving this is that the value of 4 by 5 Sn, that is equal to 1 plus 3 into 1 by 5 into 1 minus 1 by 5 raised to the power n minus 1 divided by 1 minus 1 by 5 minus 3n minus 2 into 1 by 5 raised to the power n. So on solving this we will obtain this is equal to 1 plus 3 by 4 into 1 minus 1 by 5 raised to the power n minus 1 minus 3n minus 2 into 1 by 5 raised to the power n. And if we solve these values, the final answer you are getting it is in this form, that it is 35 by 16 minus 12n plus 7 divided by 16 into 1 by 5 raised to the power n minus 1. So this is the sum up to n terms. This is the sum up to n terms. Next we have to calculate the sum up to infinity. So to calculate the sum up to infinity we are talking about S infinity, we are writing it is 1 plus 4 into 1 by 5 plus 7 into 1 by 5 square plus 10 into 1 by 5 cube and so on up to infinity. If we multiply it with 1 by 5, we get 1 by 5 into S infinity, that is equal to 1 by 5 plus 4 into 1 by 5 square plus 7 into 1 by 5 cube and so on up to infinity. Now if we subtract these values, the answer we will get it is 1 minus 1 by 5 into S infinity, that is equal to 1 plus 3 into 1 by 5, 1 by 5 square, so on up to infinity. So this value we are saying it is minus 1 by 5, and the sum of these terms we are writing it is, sum of these terms we have, it is 1 minus 1 by 5 means we are saying it is 4 by 5 into S infinity is equal to 1 plus 3 into 1 by 5 over 1 minus 1 by 5. This is equal to 1 plus 3 by 4, that is equal to 7 by 4. So we get the value of S infinity is equal to 35 by 16. So this is the value of infinite terms, sum of infinite terms. Next is, if the sum to infinity of this series is 35 by 16, we have to calculate the value of x. So we are saying that S infinity, that is equal to 1 plus 4x plus 7x square plus 10x cube plus 1. Now if we multiply this with x, we are getting x into S infinity is equal to x plus 4x square plus 7x cube plus so on up to infinity. Now if we subtract both these equations, we obtain 1 minus x into S infinity, that is equal to 1 plus 3x plus 3x square plus 3x cube and so on up to infinity. So this is equal to 1 plus 3 into x plus x square so on up to infinity. This is equal to 1 plus 3 into the sum of infinite terms, it is x over 1 minus x. We are assuming that x is less than, mod of x is less than 1. We are saying this thing is holding only when mod of x is less than 1, otherwise this sum is not possible. So we get the value of S infinity is equal to 1 by 1 minus x plus 3x by 1 minus x square. So this is equal to 1 minus x square, 1 minus x plus 3x. So this is equal to 1 plus 2x over 1 minus x square. and the sum of all these values, it is given to be equal to 35 by 16. So it is being given that 1 plus 2x over 1 minus x square, that is equal to 35 by 16. And on solving this, we will obtain 35x square minus 102x plus 19 is equal to 0. So this implies a 7x minus 19 into 5x minus 1 is equal to 0. So this gives us the value of x is 19 by 7 or 1 by 5. Now the value of x cannot be equal to 19 by 7 because we are saying that this series is convergent only when mod of x is less than 1. So the value of x we obtain, that is equal to 1 by 5. So this is the value of x that we obtain. Next is find the sum of the series this, and it is being given that mod of x is less than 1. Now if we compare the coefficients over here, we are saying 2 square x over 1 is not equal to 3 square x square over 2 square x. It is not a GP. This is not an AP. And further, 2 square minus 1 is not equal to 3 square minus 2 square. So the coefficients are not in AP. So we are saying that we have to convert the terms in such a way so that the resulting sequence is in, the resulting coefficients they are in AP. So what we are going to do over here, we are saying that suppose s infinity is equal to 1 plus 2 square x plus 3 square x square plus 4 square x cube and so on. Now if we multiply both sides of this equation, with x, we get s infinity is equal to x plus 2 square x square plus 3 square x cube and so on. Now if we subtract both these equations, we will obtain s infinity into 1 minus x, that is equal to 1 plus, from these values we are getting 2 square minus 1x plus 3 square minus 2 square x square plus 4 square minus 3 square x square x cube and so on. So if we write the terms over here, we are getting 1 minus x into s infinity, that is equal to 1 plus 3x plus 5x square plus 7x raised to the power 4 and so on. Now this sequence, look at this sequence, this is an arithmetic geometric series. So if we write the sum of this series, if we want to calculate the sum of this series, suppose we are writing s infinity dash, that is equal to 1 plus 3x plus 5x square plus 7x raised to the power 4 and so on. X into s infinity dash is equal to x plus 3x square plus 5x raised to the power 3. This is x raised to the power, this power it is cube over here, this power it is cube over here and so on. Now if we subtract these values, we obtain s dash infinity into 1 minus x, that is equal to 1 plus 2x plus 2x square so on up to infinity. This is equal to 1 plus 2 into x plus x square so on up to infinity. This is equal to 1 plus 2, the sum of this infinite series, x mod of x is less than 1, and sum of this series it is x over 1 minus x. So what we are getting from this is, we are having the value 1 minus x into s infinity. We are writing this is equal to s dash infinity. So we substitute this value over here. We obtain that 1 minus x square into s infinity, that is equal to, when you solve this term, you will obtain 1 minus x plus 2x over 1 minus x. So this is equal to 1 plus x over 1 minus x. So we are getting that s infinity is equal to 1 plus x over 1 minus x cube. So this is the sum of this infinite series. So one thing is clear over here, that this series, it is not an arithmetico-geometric series, but we have rearranged the terms, or we have performed these operations, and we have obtained a series which is an arithmetico-geometric series. We have calculated the sum of this series and we have obtained this answer. That S infinity is equal to 1 plus x over 1 minus x whole cube. This is the final answer we have obtained.